Hello everyone, you are welcome to solve this nice definite integral. We have the limit from 1 to 2 of 15x to the power 6 plus 9x to the power 3 minus 12 over 3x to the power 3 dx. So the next step here, we have the integral from 1 to 2. We can express this as 15x to the power 6 divided by 3x to the power 3 then plus 9x to the power 3, 9x to the power 3 divided by 3x to the power 3, subtract 12 over 3x to the power 3, everything here dx. So the next step here, we have the integral from the limit 1 to 2. Now here, we simplify here. We can simplify here by 3, 1, 15 divided by 3, this is 5. But here we have x to the power 6 over x to the power 3. This is in the form of a to the power n over a to the power m, which we can express as a to the power n minus m. So this implies that here we have 5 raised, that is 5x raised to the power 6, subtract 3, 6 minus 3, then plus, in the second part here, x to the power 3 and x to the power 3 simplifies. So we have 9 divided by 3. This is equal to 3. So we have 3 here. Then subtract 12 over 3x to the power 3. So in this case, we simplify 12 here by 3. So we have here 4. So subtract 4 over x to the power 3, close the brackets here, dx. Now, the next step is that we have the integral from the limit 1 to 2 of, this is 5x to the power 6 minus 3, this is 3, then plus 3, subtract 4, this is 4 times 1 over x to the power 3, into close the bracket here, dx. So we have that 1 over x to the power 3, this is in the form of 1 over a to the power n, which we can express as a raised to the power minus n. Applying this property, then here we have the integral. Remember from the limit 1 to 2, here we have 5x to the power 3 plus 3 minus 4, this is 4. Here we have 1 over x to the power 3, which is in this form, so that we can express this as x to the power minus 3. So we have minus 4x to the power minus 3 dx. The next step from here, we can be able to express this again as the integral from 1 to 2 of 5x to the power 3 dx, then plus the integral from 1 to 2 of 3 dx. We have this 3, so 3 dx, minus the integral from 1 to 2 of 4x to the power minus 3 dx. This is also dx. Now, as you can see here, we have the constant values here. Now, we can shift this constant value here. Since 5 here is a constant term, we can shift this 5 up to here. We have 5, the integral from 1 to 2 of x to the power 3 dx, then plus, now here, we have a constant 3 here. We can express this as 3, the integral from 1 to 2 dx, then subtract. Now here we have 4x to the power minus 3. So this is a constant. Again, we can write this as 4, the integral from 1 to 2 of x raised to the power minus 3 dx. Now, from here, applying the power rule property of integration, that is the integral from the limit a, b of x raised to power n, we can integrate this as x to power n plus 1 over n plus 1, then the limits a to b. So applying this power rule property of integration, we can integrate this function, as follows. Now applying this power rule property of integration, then here we have constant 5. Now we have x to power 3. We can express this as x to power 3 plus 1. Remember, this is n plus 1, so it's 3 plus 1 over 3 plus 1. And then we have the limit from 1 to 2, then plus. Now if you check here, we have constant 3, so we have 3. Here we have dx. Now something you need to check here, this is the same thing as 1 dx. Remember that 1 can also be expressed as x to power 0. So in other words, here we have x to power 0. Applying this property, this is this to power 0 plus 1 over 0 plus 1. Then we have the limit from 1 to 2. I hope you're following this. Then subtract 4 here. Subtract 4. We have x raised to power minus 3. So we have x raised to power minus 3 plus 1 over minus 3 plus 1. Again, we have the limit from 1 to 2. The next step from here we have 5 multiplied by, here we have x raised to power 3 plus 1, this is 4, divided by 3 plus 1, which is 4. Then the limit from 1 to 2 here. Then plus, we have 3. This is x raised to power 0 plus 1. So this implies we have x raised to power 1, because 0 plus 1, this is 1, divided by 1. Okay? Then the limit from 1 to 2. And then subtract here, we have minus 4. We have x, we have minus 3 plus 1. This is minus 2 over negative 3 plus 1. This is minus 2. And then the limit from 1 to 2. Another thing here, we have 5 multiplied by. Now let's substitute the limits here. So we first fix this, the upper limit. The upper limit is 2 and the lower limit is 1. So we have x to power 4, that is 2 to power 4 over 4. Subtract, here we have 1. So we have 1 raised to power 4 over 4. Close the bracket here. Then plus, here we have 3. This is 3 times x. Now, in this case, we'll have x here is 2. We have 2. Subtract the lower limit here, which is 1. And then subtract again the third part here, which is minus 4. Now, this is x raised to power minus 2 divided by negative 2. So since this is negative, negative and negative here simplifies. And we simplify again here. We simplify by 2, 1. 4 divided by 2, this is 2. And then the limit from 1 to 2. So this implies that here we have 5 into the parentheses here. 2 to power 4. 2 to power 4, this is equal to 16. So we have here 16 over 4. Subtract 1 to power 4, this is 1 over 4. Close the bracket there. And then plus, this is 3 into the parentheses. 2 minus 1, this is 1. And then we have here plus. Now this is 2 x to power minus 2. And then we have the limits from 1 to 2. Now, the next step from here, we have 5 into the parentheses, 16 over 4. remember this is, if you simplify here by 4 by 4, this is 4. So this is 4 minus 1 over 4. Close the bracket. Then plus 3 times 1, this is 3. Then plus, here we have x raised to power minus 2. We have x raised to power minus 2. Now, this is in the form of a raised to power minus 1, which we can express as 1 over a. So applying this property, x to power minus 2, this is the same thing as 1 over x to power 2. So let's substitute this. Here we have 5 into the parentheses. The LCM here, 4 is our whole number, so this is over 1. So the LCM here is 4. We have 4 divided by 1, which is 4 times 4. This is 16. Subtract 4 divided by 4 is 1 times 1. This is 1. Close the bracket there. Then plus 3. And then now plus, here we have, this is 2 over x to power 2. Then we have the limit from 1 to 2. So from here, we have 5 into the parentheses, 16 minus 1, this is 15 over 4. Close the bracket, then plus 3. And then now plus, let's substitute the upper limit first, subtract the lower limit. So we'll have 2 over 2 to power 2, subtract 2 over x to power 2, which is now 1 squared. Close the bracket. I hope you're following this. If it is your first time you come across videos from this channel, kindly like and subscribe. And hit that subscription button so that you can be notified whenever I upload new exciting videos like this one. Now, this is equal to 15 times 5. This is 75 over 4. Then plus 3. Then plus, now here we have 2 over 2 squared. This is equal to 4. Subtract, now 2 over 1. This is the same thing as 2. So this implies that here we have 75 over 4 plus 3. Then plus, now here we have 2 is a whole number here. So the LCM here is 4. 4 divided by 4, this is 1 times 2. This is actually equal to 2. Then subtract 4 divided by 1. This is 4 times 2. This is now 8. Close the bracket. Now let's proceed. Now here we have, this is 75 over 4 plus 3. Then plus, this is 2 minus 8. And this is actually equal to minus 6 over 4. Let's simplify here. This is minus 6 over 4. So we can simplify here. 6 divided by 2, this is 3. 4 divided by 2, this is 2. And then now, the next step is we have 75 over 4 plus 3. Then subtract 3 over 2. So 3 is our number, so this is over 1. All right? So let's get the LCM here. The LCM here is 4. So that we have 4 divided by 4 here. This is 1 times 75. So we have 75. Then plus 4 divided by 1. This is 4. 4 times 3. This is actually equal to 12. Then subtract 4 divided by 2. This is 2. 2 times 3. This is equal to 6. And therefore from here, this is the same thing as we have 75 plus, now 12 minus 6, this is equal to 6 over 4. So this implies that here we have 75 plus 6, and this is equal to 81 over 4. And actually, this is the final solution to this definite integral problem. So this is the solution here. So I hope you are following the steps Kindly follow the steps again, watch this video till to the head, and kindly like and subscribe. Kindly like and subscribe and share. Thank you for watching. See you in the next video. Bye bye.